testing. Alright, Geyer Partners, J. Paul Geyer, P-E-R-A. The foundations on filling and backfilling. Types of fill, foundation, compacted fill, compaction requirements, placing control and backfill, filling sediments, hydraulic fills. This publication is adapted for the Unified Facility criteria of the United States government, which for public domain have been authorized and limited distribution and are not copyrighted. The figures and tables of formula publication may at any times be a little difficult to read, but they are best available. They are the best available. Do not purchase the publication if limitation is not acceptable to you. Alright, type of fills. Fills include conventional compact fills with hydraulic fills, uncontrolled fills, soils, industrial, domestic waste such as ash, slag, chemical waste, building rubble refuses. Properly placed compact fill will be more rigid and uniform and have greater strength than most natural soils. Hydraulic fill may be compacted, uncompacted, economical means of the providing filling over a large area except for the cohesion materials, i.e. cleaning sands, gravel, the place under control conditions so silty pockets are avoided, and areas compacted with the place hydraulic fills which generally require some type of stabilization to ensure adequate foundations. Uncontrolled fills are likely to provide variable bearing capacity, result with non-uniform settlement. They may contain injurious chemicals and in some instances may be chemically active to generate gases that may be being conducted away from the structure. Foundations on fill in second and third groups. The first group is not adequately compacted but should be subjected to detailed investigation to determine their suitability for supporting a structure. Elsewhere, they should be avoided. Unsuitable fills often be adequately stabilized. 2. Foundation compacted fills. Compacted fill beneath foundations. Compacted fill beneath the foundation necessary to raise the grade of the structure above the existing ground, replace unsatisfactory surface soil with the fill constructed above the natural surface, increase load underlying soils covered with large settlements with the less construction structure and is postponed under the till fill induced settlements have been taking place. Settlements beneath the proposed fill can be compacted using methods outlined in technical literature. If computed settlements are excessive and considered surcharging, postponing construction until expected settlements under the permanent fill loading has occurred. Extending the fill well beyond the loading area except where the fill is placed against the cut slope, where the fill is relatively thick and is underlying by soft materials. Check its stability with respect to the deep sliding. If the fill is underlain with the weaker materials found with the footings on the fill, unless the settlement is excessive, the fill is underlain by the strong material. The footings may be found on the fill with a stronger material. 2. Foundations partially unfilled. When sloping ground surface with a variable foundation depth with the result of the supporting foundation partially with the natural soil of the rock permanently or partially compacted filled settlements and also required with the estimate different settlements within the general of the vertical joint in the structure should be provided with suitable architectural treatment with the junction between the different segments of the foundation. Subgrade beneath the portion of the foundation to be supported on natural soil or rock should be undercut about 3 feet and replaced by compacted fill that is placed at the same time as the fill of the portion is to be supported with thicker compacted fill. Location of borrow. Explanation investigate that it should be made to determine the suitable source borrow material. Laboratory tests determine the suitability of available materials include natural water contents, compaction, characteristic grain size, distribution. Arterberg limited shear strength and consolidation. Typical practice for the compacted material with the preliminary analysis of the given in Table 1 accessible with frost action should be considered in analyzing potential behavior of filled material scope. Laboratory testing compacted sample that depends on the size of the caustic structure, thickness, extent of the fill, also for the strength of the compressing of the underlying soil, with the coarse grain soil, with the preferred for the fill. However, the most fine grade soils can be used with advantages if the attention is given to the drainage compaction requirements, compaction, moisture, and the density control. 2.4. Design foundations of fill. Foundations can be designed on basis of the bearing capacity settlement calculation. Settlement of the bearing capacity of the underlying foundation soil also should be evaluated partially. Practically at all times, construction can be found with a compacted fill provided with the structure is designed to tolerate anticipated settlement. If the fill is properly placed and compacted, good continuous field inspection is essential. Site preparation. The site should be prepared by cleaning, grubbing all of the grass and trees, etc. Save with as many trees as possible. Environmental conservation. Topsoil should be stripped with a stockpile of the land. Later, landscape of the fill with the borrow areas placed with the compacting fill should preferably be done when the area is still unobstructed by footings and other construction. Adequacy with the compacting of the fill with the superstructure with the dependent chiefly on the uniformity of the compaction effort. The compaction equipment that generally can be used economically efficiently Only on large areas, adverse weather conditions may be pronounced effect on the cost of the compacted fill that are sensitive to placement, moisture content, i.e., and materials having more than 10 to 20% finer than number 200 sieve, depending on the gradation. Site problems. Small building areas with congested areas where many small buildings, utilities, and lines surround with the site. Present with difficulties in regard with the maneuver to large compaction equipment backfilling adjacent to the structure. Also present difficulties and power. Hand tamping equipment must be employed with considerable care to necessary to secure uniform compaction. Alright, 3. Compaction requirements. General with the guidelines of selecting compaction equipment. For the establishing compaction requirement of the various soil type that given in the table of 1, fill materials have been thoroughly investigated. Their ample local experience with compacting them, and it is preferably specify the details compaction perceived with the displacement of the water content, the lift thickness, type of the equipment, the number of passes with the soil of the fill, the type of the construction. The type of the compaction equipment that is not known beforehand. Specification should be made for the desired compaction result of the specified minimum number. Curvature of the suitable equipment of these assure of the uniform compaction density. Compaction specification. For most project placement, water content and soil sensitive compaction moisture should be given with a range of -1 to 2% optimum water content field compaction effort applied to each layer of the compacted, not less than percentage maximum density specified in table 2. It is generally important to specify the high degree of the compaction fills on the structure for the minimized settlement to ensure the stability of the structure. In addition to the criteria set forth in general technical literature, in the following factors should be considered with establishing specified requirement. The sensitivity of the structure total differential settlement or as related to the structural design, particularly with the characteristic of the structure to be found partially on fill or partial on natural ground. If the ability of the normal compaction equipment is to produce the desired density of the existing locality available to material with a reasonable range of the placement of the water content is considered with essential, special equipment should be specified. Compaction requirement for clean and cohesionless granular materials will be generally higher than those of the cohesive materials because the cohesionless materials are readily consolidated, liquefied with the subject of the vibration from structures unusual stability, requirement settlement limitation, minimum density. Requirements indicated in the table of 2 should be increased for the coarse grain, well-grade cohesion soils with less than 4% passing. Number 2, C for poorly grade cohesive soils with less than 10% of the material should be compacted with a higher practical water content, preferably saturated compaction. Vibrator rollers generally the most effective procedure. Experience with indicate the previous material of the compacted average relative to the density of the 85 to plus 5% with no practical difficulty. The cohesion material stipulated with the fill will be compacted either to a minimum density of 85% relative to the density of the 95% of the cohesive or the CE 55 compaction effort, whichever the gives the greater density. If it is necessary to use fill material, have the tendency to swell, the material should be compacted with water content somewhat higher with the optimum and no greater the density required with the stability under proposed loadings table 2, but the varying capacity of the settlement characteristic of the fill under these conditions should be checked by laboratory tests, and else swelling clays can in some instances be permanently transformed into soil lower plasticity, swelling potential by adding a small percent of the hydrated lime. Compacted rock, compacted crushed rock, and provides an excellent foundation fill. Vibratory rollers are preferred with the compaction rock. Sediment of the fill under the action roller provides with the most useful information to determine the proper loose fit, thickness, and number of the passive roller type of material radiation. Compaction with a 10-ton vibrator roller is generally preferably with the rock should be kept watered at all times during the compaction with an abative collapse settlement of the loading in the first wetting. As the general criteria of the construction control testing rock fill are not available, the test fills should be employed with the previous experience with inadequate with the large important rock fills. Shows a table that is too small to read, which is a summary density method of building foundations. Alright, then it shows the CE maximum density cohesive soil, cohesionless soil, fill, embankment, backfill. Under proposed structure building steps and paved, 90% fill and backfill, 95% cohesionless soils. Under sidewalks and grass area, 85% cohesion soil fill, embankment, backfill, and 90% cohesionless soil. Subgrade under building slab steps, paved under top of the 10 inches, 90 grade fill and backfill, 95 cohesionless soils. Under sidewalks, top 6 inches, 85 fill embankment, backfill, cohesive soil, cohesionless soils, 90. Alright, 4. Place control of the backfill. Backfill should be placed lifted no greater than shown on the table of the 1, preferably 8 inches left, depending on the soil. Of the type of the equipment available, the no backfill should be placed with the containment of the frozen lumps. If the soil of the later thawing will produce the local soft spots, backfill should not be placed on muddy, frozen, frosted ground, frost-covered ground. Method of compaction control of the during construction or described in technical literature. Or 5. Settlements. A fill thickness of even 3 feet with a considerable soil load will increase with the stress with a substantial depth of approximately 2b, where b is equal to the small lateral dimension of the fill. Stress in case of the fill may be larger than those of the structure footings placed on the fill. The procedure outlined with the technical literature of the obtained expected settlements of the fill loading. Many fills are variable to thickness, especially within the area landscape view, with both cutting and the filling with the construction site. Similar case of attention should be given in the building content location. With respect to the cross-cutting filling in line with the proper type of the building settlement that can be designed. Building may act as a cantilever over 1/10 to break off the edge of the beam where the interior sags. Proper placing reinforcing steel within the wall footings, top of the cantilever action, bottom of the simple beam action may be to help with the building control. Building correct with a settlement inevitable with the building joints can be provided with a critical location if necessary. Applying effect with the structure 1 or 2 story resident of the fill with loading off the fills with a 10-foot thickness on sound soil with the the compaction control should not produce a differential settlement either with a smooth curved hump or slag of 1 inch in 50 feet or a uniform slope of 2 inches in 50 feet. 6. Hydraulic fill. The hydraulic fills are placed with the land underwater with the pumping material through the pipeline with the dredge, bottom with the dumping of the barge of the dredge material with the various from sand, fine silt, fine grade silty clay, and the clay is extensive with the materials maintenance of dredging in the United States as a result of the disposal layer of the dredge material with especially attractive with the economical standpoint of development. Purpose of the dikes are usually required with the retained hydraulic fill with the land may be feasible with the underwater fill with the underwater dikes may be constructed with a large stone with the gravel. The pervious fills, hydraulic paste, pervious fills less than 10% of fines generally with a relative density of 50-60%, with locally be lower the control placement necessary to avoid silt concentration compaction be able to reduce the relative density sufficient of the foundation support. Table 1. Existing unpacked hydraulic soil fills with the previous material of the semi-seismic areas and subject to the liquefaction desensitification required important structures that are to be found within such deposit with a rough estimate of the relative density may be obtained with the standard penetration resistance. Undistributed borings will require to obtain more precise evaluation and the suit density obtained with the undistributed samples with the cyclic triaxial testing. If required, new fills and courses material economic available should be used unless special provisions are made. The removal of fines bureau contain more than 10% fines passing the number 200 C should be avoided. Even the control placement is necessary to avoid local silt concentration. Alright, fine grade fill with the hydraulically placed over consolidated clay is excavated by the suction driven to produce the fill of clay balls and fine with the wastewater permitted to run off the slope. Such fill will extremely flat range from about 12 to 16 H on 1V. These fill will undergo large immediate consolidation about first 6 months until the clay ball will destroy the void to close the void space with the additional settlements from the 1 year period at this time, a total of 3 to 5% fill height. Or maintenance dredging and hydraulically placed normal consolidated clay will initially be the water contents between 4 to 5 times the liquid limited depending on the measure taken within due for the surface of the drain, but it will take approximately 2 years before the crust to the conform sufficient for the support light equipment with the water content of the underlying material. The approach with the liquid limited placing 1 to 3 feet. Cohesion less the burrow can be used to improve these area with the rapid leach of the can be support surcharges. Fills with or without vertical sand drains to accelerate consolidation. Consolidation substantial 1 or 2 story buildings and spread. Foundation can be used without objection. Settlement of the considerable care must be to use applying the surcharge so that the shear strength as well as not exceed use light equipment. Settlement to hydraulic fill. The coefficient permeability of the hydraulic fill is less than 2/10,000 of an inch per minute. Foot per minute. 2/10,000 of an inch foot per minute. Consolidated time for the will be long prediction of the behavior of the complete with the fill will be difficult coarse grain material large coefficient permeability fill consolidation strength of the build-up the relatively rapid reasonable strength of the estimate that can be made where the fill and foundation soil with a fine grade with low efficiency permeability Piezometers should be placed in the bowl of the fill with the underlying soil to monitor the pore pressure, dissipation. It may also be necessary to play with the settlement to play with the monitor the settlement, depending on the thickness fill with the settlement placed. They may be placed both on the underlying soil of the will of the fill. Observe the settlement rates and amounts. Compaction of hydraulic fill with the dike land. Hydraulic fills can be compacted as they are placed by use. Driving track type tractors back and forth across the saturated fill. Relative density 70-80% can be attained with the manual of the cohesion materials. 6242. Other methods of vibratory rollers, vibro flotation treat, terra probing, compaction pile with bellow, water, and hydraulic fill can be compacted by using tetra probing, compaction piles, and blasting. Underwater hydraulic fills. For structural fill, play with the dredge bottom with the remove of the fine dispersion dredging, final sweeping operation, preferably with a suction dredge. For placing the fill with the extremely flat slope at the edge of the fill of the void for excessive turbulence during the dumping of the fill material. Placing camshell shoving off the side of the deck barges to obtain relatively steep slope with underfill. Use mixed sand and gravel to burrow with containing with about equal amounts of sand and gravel. The underwater slope with the C with the 1V and 2H may be achieved with a careful placement. Uncontrolled bottom dumping as barges through the greater depth of water will spread the fill over the wide area to confine such fill. Provide with the berms and dikes course variable material stone fill on the fill perimeter. Alright, and then it goes in the file exam, and this has been an introduction to foundations and fill and backfill.